Welcome to the second of these three lectures on multi-level explanation. In the last lecture we looked at how reductionists deny the autonomy of the special sciences. Special sciences fail to be autonomous because in a real sense they're logically contained within the more basic science of physics. In this lecture we're going to look at how, according to the reductionists, mind has no autonomy either. This is a straightforward application of the position, the more general position on the special sciences to the mind. We'll then look at the problem of multiple realization and how it generated an anti-reductionist consensus, which includes a position that's called non-reductive physicalism, and also various forms of pluralism in the philosophy of science. We'll conclude by looking at some criticisms of reductionism, some ways that the reductionists can push back. So here are the three phases. We'll start with ambitious reductionism, which grew up in the late 1960s, and one particular form of it we'll examine is the mind-brain identity theory. We'll then look at multiple realization and non-reductive physicalism, and a very famous paper by Jerry Fodor arguing that multiple realization entails that the special sciences are in an important sense autonomous. And we'll then look at four versions of pluralism in the philosophy of science associated with John Dupre, Nancy Cartwright, Sandra Mitchell, and finally James Ladyman and Don Ross. The mind-brain identity theorists contend that the mind and the brain are the same thing. They contain also that states of the mind and states of the brain are the same thing. So for instance, pain, which is a feeling, is a physical process. As we'll see, as you can see in the identities I've listed on this slide, pain in the 1960s was thought to be identified with C fibers firing. We'll carry on with that for the purposes of our discussion. Now here's an objection. If the mind is the brain, how come science had to discover that? Well, the mind-brain identity theorists do think that the identity of the mind and the brain had to be discovered by science, and that's a plausible part of their position, in that there was a specific time at which it was discovered that the brain is the seat of consciousness. If you look at, for instance, early modern thinking about where the soul is, it might be in the heart. There are all sorts of other places it might be. But there is a question that if x equals y, and I know the meaning of x, and I know the meaning of y, why don't I know that x equals y? Well, here we've got to make a distinction between identity and identity statements. So it might be true that that x equals y, but I might not know it. For instance, Superman may be Clark Kent, but of course, as everybody knows, Lois Lane doesn't know that Superman is Clark Kent. So she doesn't make inferences about Superman given the information she has about Clark Kent, and vice versa. So that discussion brings into play a principle brought forward by Leibniz, a 17th century philosopher, called the indiscernibility of identicals. He had also proposed a converse principle, the identity of indiscernibles, which doesn't concern us just now. But the indiscernibility of identicals tells us that anything that's true of x is also true of y if x equals y. So we can, because x and y are indiscernible if they're identical. And this means that any statement we have about x can be turned into a statement about y and vice versa. and if one's true, the other will be true. And this is put in the complex Latin phrase that the two x and y are substitutable salva veritate, that is, saving the truth. Now, of course, it's not always true, and this is the important point, not thought about by Leibniz, but considered by philosophers in the 20th century. It's not always true that we can substitute x for y, even if x and y are identical. And this is because there exist things called intentional contexts. So, for instance, let's consider Lois Lane. Lois Lane knows that Superman can fly in the air. She doesn't know that Superman is Clark Kent. Therefore, she doesn't know that Clark Kent can fly in the air. So, in the case of an intentional context, the context that follows Lois Lane knows that, we've got to suspend substitutivity, salva veritate. So that covers why we can't automatically know a priori just by knowing the meaning of the mind and the brain, the words the mind and the brain, that the mind is the brain, even if it's true that the mind is in fact the brain. So with this all in mind, the mind-brain identity theorists look to certain scientific identities as a model for their claim. So we saw in the last lecture how the ambitious reductionists thought of thermodynamics, including the notion of temperature, to be reducible to statistical mechanics and via the notion of mean kinetic energy. We saw that they also identified water with H2O. So, in principle, claims about water should be deducible from claims about H2O. And they liken these two examples, which they think are reductive truths, identities which ground reductions. They think similar claims can be made about the identity between panes and C fibres firing. Now this is a little problematic because there are definitely differences between the identity water equals H2O and the identity pane equals C fibres firing. So one immediate difference is the evidence we have available to it. So if we look back in the history of science, the claim that water is H2O was established by a long process of experimental investigation by chemists. Lavoisier, in a particular stage of that process, showed that water is a compound of hydrogen and oxygen by taking some water and weighing it, reducing it to its elements, hydrogen and oxygen, and weighing the elements and finding that they weigh the same together as the water did. So all of the water has been, as it were, divided into hydrogen and oxygen. You then recombine the hydrogen and oxygen to make some water, which was, again, pretty much the same weight as the original starting water and the joint weight of the hydrogen and oxygen. So he's taken us through a process of analysis and synthesis. So he's analysed the water into its component elements, and then he's resynthesized them. That's a very strong kind of argument for the identity. And that's just simply missing. No one's taken some C fibres and turned them into pain in the same sort of way. We don't have the same argument from analysis and synthesis. So the evidence is lacking for that identity in comparison to the identity of water as H2O. A second point, which I touched on in the last lecture, and I shall come back to, is that water is H2O. Well, what it really means is that the macroscopic substance water is composed of H2O molecules, and that can be a complicated relationship. So what water is identical with is something that's made up of H2O molecules. And it remains to be seen whether that entails the reducibility of the water to the H2O molecules. In fact, I argue that it's not so reducible. So where do these observations get us to? Well, mind-brain identity theorists concentrate on identifying the properties and processes of the mind and the brain. Thus, for instance, sensations, emotions and thoughts, they claim, are identical with various neural events, properties and processes, things happening, physical things happening in the brain. And the emphasis is properly on the word physicalism. By this, mind-brain identity theorists take the category of the material to be a smaller category than the category of the physical. So, for instance, there are physical things which are not simply material. So material things, they're thinking of things which are relatively solid, made of matter. Whereas there are some physical things, sounds, radiation, which are physical but not material. They put forward a non-definitional and non-deductive physicalism. So we've seen what physical is. What does it mean for it to be non-definitional and non-deductive? Well, the position is non-definitional because mind and brain, the words mind and brain, don't have the same meaning, even if they in fact refer to the same things. So that again sounds a bit puzzling. We discussed that in the last slide, but the key distinction here is between sense and reference. So when we say they don't mean the same thing, they don't have the same sense. That is the, as it were, the information they carry to people who are thinking about them. But they might still have the same reference, so they might point to the same thing out there in the world. So a famous example introduced by the architect of the initial distinction between sense and reference, Gottlob Frege, which was the morning star and the evening star and Venus. So the morning star is a star that appears close to the horizon just before sunrise. The evening star is a star that appears in the night sky just after sunset. In fact, astronomers now know they are the same thing, but the sense of the words the morning star is different because I just defined it for you, and it's different from the sense of the words the evening star, but they have the same reference, which is in both cases to the planet Venus. So this position is set out by David Lewis in 1966 and J.J.C. Smart in papers right through the 1960s and in the Stanford Encyclopedia of Philosophy article from 2007. We'll now move on to multiple realization, which is one source of difficulty for the mind-brain identity theory and, in fact, any form of reductionism. Multiple realization is simply the idea that higher level properties might have different kinds of realization in the real world. Realizations which are quite distinct from a physical point of view. So one source of claims about multiple realization is functionalism, an idea associated with Putnam in 1967 and various architects of computers. So there's a long tradition of literature and philosophy taking the latest technological developments as ways of thinking about the mind and the body. So, for instance, the recent discovery of electricity was thought to provide as it were, the spark of life, and this was part of the story of Mary Shelley's Frankenstein. Earlier than that, during the early modern period, clockwork was taken as a metaphor for, or of a way of thinking about the mechanical workings of something like the human body, which might be thought of as clockwork. Functionalism takes the mind to be a computer, this form of functionalism. Now, the important thing about a computer is that it's got a program. And the idea is that the states of the computer, which are determined by the operation of the program, are defined by their inputs and their outputs at the level of the software. And a computer programmer can make a computer do what they want it to do merely by loading the right software onto the computer and giving the computer the right instructions, the right inputs. And then the computer will go through a series of states and come to a final state, which we might regard as the output. Another important point concerns the autonomy of software. So one could write a computer program and run it on different computers. Each of them will be slightly physically different. More generally, more abstractly, one might have different programs that do the same thing. For instance, storing information of a certain kind, and they might do it in different ways at the software level, which are also different at the physical level. Now, this functional perspective on the mind would have its limits. So if we think about it, the inputs and outputs are something that are available from a third-personal perspective. But a first-person perspective, though, as it were, what a particular experiences feel like, and if we think of sensations as it were, genuine properties or states of the mind, functionalism won't be able to properly characterize them. So in a very famous example, due to Ernest Nagel, he asked, what is it like to be a bat? Now, one might study bats and their behaviour and know what kinds of physical stimulus affect them and how those physical stimuli affect their behaviour. But one still wouldn't know what it's like to be a bat. That's the thought, as it were, the sensation of being able to sense things by echolocation is something which we simply don't have. And functionalism doesn't get you to the contents of experience. One can apply that to each of us. So functionalism, as it were, leaves out the what it's like of seeing yellow or smelling coffee or hearing a particular piano chord. These are only things you can get knowledge of, the what it's like, by direct experience, and functionalism would just characterize them in terms of their inputs and outputs, which is a limited perspective. I'm now going to introduce you to a very famous argument given by Jerry Fodor in 1974, and which has been very influential in the philosophy of mind and in parts of the philosophy of science, to the effect that multiple realization entails the autonomy of special science laws. Fodor begins by distinguishing between the generality of physics and the unity of science. So the generality of physics is the universal applicability of physical laws. So for instance, the law of gravity applies to everything without anyone thinking that it determines completely how things go. So the law of gravity is one constraint on the behaviour of physical systems. The same, for instance, might be said of the second law of thermodynamics. So that's the generality of physics. And that's underwritten by the fact that everything's material and everything physical has got physical properties. So those physical properties, for instance, the mass of a body or its temperature, the energy it contains, they are subject to physical laws, so they will be an influence on its behaviour without us thinking that they determine its behaviour. Oppenheim and Putnam, as we saw, made a much stronger claim that they called the unity of science. It's not what people always mean by the unity of science, but Oppenheim and Putnam meant that everything is derivable from physical laws. Clearly that's a much stronger claim than the claim about the generality of physics. A second point in Fodor's argument is that, in one sense, multiple realization is obvious and must lead to a qualification in the mind-brain identity theory. Multiple realization is obvious because, for instance, we attribute the same sensations, the same kinds of sensation to octopi and to human beings. Octopi and human beings have got very different neural systems. Their brains are different and their nervous systems are different. So that if they can both be in pain, that means that they must be realized, their pains must be realized by in quite different physical ways. And that's consistent with the fact that it's definitely pain we're talking about. So one can characterize pain, for instance, functionally. So we identify it in terms of tissue damage and as a typical kind of cause. So if I put my hand on a hot stove, that causes tissue damage and causes the pain. That's what makes it a pain. And it also causes a certain kind of behaviour in me, which is avoidance behaviour. I move my hand once I feel the pain. Now, without making the claim, because we bore in mind that functionalism leaves out the what it's like, we can see that the pain in humans and the pain in octopi could be similar from a functional point of view. So octopi have this kind of state that we attribute to them, which is caused by tissue damage. So you poke one of their tentacles with a sharp stick, and then they move their tentacle. So they avoid there's some tissue damage there, and the octopus avoids the cause of the tissue damage. And it's the pain that mediates that connection. So we can characterize pain and in humans and octopi in the same sorts of functional ways, but it must be realized in different physical ways. So there's a commonality at the special science level, which is not reflected in commonality or similarity at the physical level. And this is reflected in a very famous diagram from Fodor's paper, which is on the slide here. So that means if there are laws about pain and what it does, a law of special science X, that state S1 leads to state of kind S2. Well, if S1 and S2 are multiply realised, like pain is in humans, then S1 isn't going to correspond to a single predicate or property of physics, but a vast array of them. We'll need one for octopi, one for humans, one for mice, one for so on and so forth. And Fodor argues it's difficult to think that that messy, disunified thing at the bottom is a law. We can make predictions. We couldn't make predictions about it because we don't know where pain, for instance, is going to turn up next. In physical terms, we know what pain is when we see it in functional terms, that is in special science terms, but you don't know where it's going to crop up next at the physical level. So it's hard to see that there's anything corresponding at the physical level to a special science law that's concerned with pain. And that, says Fodor, entails that the higher level law is irreducible and to that extent autonomous. Now, Fodor's argument gives us motivates a kind of position. We note the generality of physics, that everything's concrete has got physical properties, so both I and the octopus have got physical properties, although our pain is realised in different ways. We have to recognise that although everything might be in some sense physical, it's not necessarily going to be the case that we can have physical laws, underlying physical laws, which entail special science laws. So in other words, we accept physicalism and the failure of reduction, which gives us a position that we call non-reductive physicalism, which is a very, very influential position in the philosophy of mind in the 1970s going onwards. So with that in hand, I'm going to move on to some anti-reductionist positions in the philosophy of science, which all fall under the broad category of pluralism. The first of these versions of pluralism in the philosophy of science is due to John Dupre. John Dupre is a philosopher of biology, and his initial work concerned classification in biology, and particularly the notion of species. Dupre argued, and argues in this influential book, The Disorder of Things, that there's no one concept of species, even in biology. So different parts of biology, for instance, molecular biology and evolutionary theory and ecology, they all define species in different ways, different and non-equivalent ways. And these ways are relevant to the ways that those parts of biology have of thinking about species. So they're relevant to their theories. Dupre thinks that these are all broadly on a par. One particular point that Dupre rejects is the idea that there could be a sort of a genetic essence for being an elephant that would, as it were, be prior to all the other ways one might have of defining what it is to be an elephant. And it's this fact that, as we'll see in a moment, has some severe consequences for reductionism. So Dupre's more general position about the metaphysics of science, which he generalises from his work in biology, he calls promiscuous realism. So it's a form of realism because he thinks that science studies objective divisions in nature, but it's promiscuous because he thinks there are many such divisions in different sciences and other different kinds of human activity, which may be unscientific activities like gardening and cookery. They have their own ways of dividing up nature, and there are objective facts underlying those. So there are many cross-cutting divisions in nature which are really there and which are on a par from an objective point of view. It's our interests that makes them significant and relevant to us, and that's why we sort of focus on them in thinking about processes involving those divisions and any laws concerning them. But notice one immediate consequence for reductionism. If there's no genetic essence of elephants, then there's no sense in which there's an identity that can be identified of what it is to be an elephant in physical terms. So a reduction of elephanthood can't get going because there's no essence for it to act upon. So remember the basic claim of the reductionists was that, as it were, there was an identity of temperature with the higher level notion with a lower level notion at the molecular level. There's an identity of being water with being H2O. We might challenge those, but Dupre says in the case of elephants, it's a non-starter. We know that there's no genetic essence of elephant and therefore no microstructural essence of elephant, so it's severe consequences for reductionism follow. Reductionism is just stopped in its tracks. And more generally, he thinks that there is no evidence for the kinds of claims that reductionists make about the unity of science. So he does accept a very weak kind of physical unity, and this is kind of everything is made of the physical. So if you took away all the atoms and electrons, well, there'd be no elephants left, and there'd be no philosophers, no books, and so on. But that's a very weak principle of what one might call physical exhaustion. If you take away the physical, that exhausts everything else. So there's a kind of unity there to the world, but only a very weak kind, and that's different from the kind of unification that the reductionists thought were inevitable. But Dupre rules that as very unlikely. The next form of pluralism I'd like to look at is due to Nancy Cartwright, presented in her 1999 book, The Dappled World. Very broadly, Cartwright is committed to the autonomy and priority of practical knowledge, including experimental knowledge in the sciences. This is know-how that people have that's grounded in abilities, reliable abilities to make, for instance, various technological devices do things. Lasers, for instance. Now, we sometimes explain the workings of parts of those things in certain limited circumstances in terms of universal physical laws. But, says Cartwright, we oughtn't to assume the universality of fundamental physical laws, as it were, a priori. That applicability has got to be earned by evidence. If we don't seriously test a law as applying to a physical law as applying to some system, then we shouldn't give it the credit of applying to it and governing its behaviour. Rather than just setting out a negative position, Cartwright tries to develop an alternative metaphysics for science. She rejects the idea of fundamentalism, that there's one set of laws that make everything happen. Rather, there's a patchwork of laws corresponding to the little pieces of knowledge, practical knowledge, that we have about things. And we know that in some cases, fundamental laws do act in the absence of other laws, and then we can see them operating we can give an account of them operating, and we can then it makes sense to say that they're applicable there. In other cases, all bets are off, really. So that's the dappled world. It's a world of sunlight coming through trees. It's not a unified world. It's got lots of patches from a gnomic point of view. Now, in a 2001 article, Barry Lower uses what I call the Nobel Prize gambit against Cartwright, arguing that, well, if Cartwright thinks that universal physical laws don't apply anywhere, she ought to be able to show that, and be able to show that a physical law breaks down in some specific circumstances, because that's the sort of thing that people get Nobel Prizes for. Well, I think this is unfair, because Cartwright's making an in-principle claim, and the claim is just the same that Lower would make. I mean, if Cartwright says to Lower, well, give me a detailed account of how the fundamental physical laws apply to, for instance, this book, Lower wouldn't be able to give it, but he says, well, in principle, they're applicable. And so Cartwright is saying something similar, that in principle, that when we have a principled account, we'll be able to justify. So the evidence isn't there. So Cartwright doesn't claim to have the evidence, just the same as Lower and other reductionists don't have to claim to have the evidence. So Lower is assuming the applicability in making the criticism. So there's a fairness issue in making that criticism, putting the burden of evidence on one side rather than the other. But one can note that a weaker kind of position that Cartwright might be available to Cartwright, and other anti-reductionist positions do take it, is to make a distinction between the applicability and the completeness of laws. Cartwright does a stronger pluralist thing of suspending both the applicability and the completeness of laws. Most non-reductionists, many non-reductionists, deny the completeness of laws and may leave open the applicability of fundamental physical laws. The next version of pluralism we'll consider is that due to Sandra Mitchell in her book Biological Complexity and Integrative Pluralism. Mitchell's concern is with the structure of explanations in biology, and in particular cell biology and physiological biology, and how they integrate knowledge from different levels. The fact of this integration and the way that it works, Mitchell thinks, provides challenges to more permissive versions of pluralism. So she rejects an anything goes version of pluralism, which is something that she thinks argues has been suggested by John Dupre. But she also rejects reductionism, a position she tries to get to, which she thinks reflects the actual practice of building explanations in science and using knowledge from different levels, is that scientific knowledge at different scales is genuinely integrated, and there are autonomous insights coming from higher levels, and scientific insights from different levels are combined. The final version of pluralism that we'll consider is that due to James Ladyman, Don Ross and others in their book Everything Must Go. Theirs is the most revisionary, and it's about the least pluralistic, and it's got an overarching premise, which is that physics grounds the reality of everything, fundamental physics. This, they think, has been demonstrated by the history of science, where fundamental physics places constraints on other sciences, but the same is not true the other way around. Another method they make is to deal with scales rather than levels. So scales are a properly physical notion, scales of size. So when they're thinking about relationships between different parts of science, they're thinking about size, scales, and more particularly energy scales, because one of the things that is clear from physics is that the most fundamental processes occur at the highest energy scales, but that some fairly autonomous things happen at lower energy scales, where those events at highest energy scales just simply aren't happening. One example of that I alluded to earlier is the way in which we get this burgeoning of a great wealth of different kinds of molecular structure corresponding to different compound substances in chemistry, that's made possible by turning down the energy to trap atoms and electrons into atoms, which can then form molecular structures. Now, take all that Lederman and Ross's point is that the contributions of higher level sciences is encapsulated in the explanatory information they give us and the patterns they encode. So they think of high level entities and processes and laws as corresponding to patterns in the goings on of physical events. They accept the reality of those patterns, even though they are in some sense patterns in the physical, but the physical is definitely prioritized. And they have an argument against traditional substance metaphysics, which is part of this, reflected in their title, Everything Must Go. So their idea we shouldn't prioritize things, but we sort of see what we think of as things like tables and chairs or molecules as it were, aspects of physical reality, but they're not, as it were, from a metaphysical point of view, things in the sense of being substances. But still they claim to be realists about the patterns, the things, which aren't really things, corresponding to patterns discovered by higher level sciences. In their position, they encapsulate as rainforest realism. So it accepts a great variety of things, like the different many species we find in a rainforest, as populating the world, but looked at in this very particular metaphysical point of view that's grounded in fundamental physics. I'm going to conclude this lecture on the anti-reductionist consensus by looking at two ways in which reductionism pushes back. That's going to give us a nice entree into our final lecture on the ontological turn and the re-emergence of emergence. So one way in which reductionism pushes back has been through a critical examination of multiple realization. I'll refer here to a book by Polgren and Shapiro recently, 2016. I'll just look at one aspect of their argument. But of course, this is multiple realization is the source of a key objection, so it's very important that we can look at it critically. Polgren and Shapiro invite us to closely examine cases of multiple realization. They are to ask us, let's take some special science category which is supposedly unified at the special science level but disunified at the lower level. Well, really, how relevantly similar are other cases at the higher level, and how relevantly different are the cases at the lower level? So it could be that the similarities at the higher level are relatively unimportant, and in fact we can understand what's happening in terms of the lower level. We just don't need to consider the similarities at the higher level. And we also might consider whether the differences between the cases at the lower level, that variety we're supposed to see at the lower level, really whether it's truly a variety or whether we're just adding in, as it were, unimportant differences between really quite physically similar cases. And so they advocate a process that they think goes on in science when we have these clashes between higher and lower level, or when higher level meets lower level, of chunking and splitting. So in case of splitting, if we're skeptical about how similar cases at the higher level are, for instance, let's take pain. Really, how similar from the high level point of view is octopus pain and human pain? There are clearly differences. What do they share? At what level of abstraction can we say that octopus pain is similar in its behavioural causes and effects? So there might be real differences between the functional, either higher level nature of pain and between different species. So in other words, the unity at the higher level, it sort of evaporates. So that's splitting. We split the higher level concept, or split the cases. And then there's chunking, which is where we look at the lower level cases and think, well, those differences aren't really important. We can split them. So we can chunk them. Now these are really important cases, and they do look at some very detailed cases in some scientific contexts. But it's important to note the narrowness of their criticisms, and which are nevertheless important in their scope. The first thing is that they really only consider functionalist multiple realization, that all their cases are of that kind. So that is where the higher level categories are defined functionally, that is in terms of their typical physical effects and causes. And they don't consider any cases of functional realization in physical sciences. And as we'll see, there are some cases of that. We've already seen one in the case of temperature. They never discuss the case of multiple realization in temperature because it's not functionally characterized, and the differences at the lower level are really genuine. And we've got a theory, a well-confirmed theory at the higher level, which is not a functional theory, giving us a unification of the higher level categories, such as temperature. So their criticisms are important, have a fairly narrow focus, so I hope we'll move on. They're of real importance. The second way in which reductionism has pushed back against the anti-reductionist consensus concerns looking critically at the anti-reductionist position from an ontological perspective. Now, getting ontologically serious, as the phrase goes, means making clear distinctions between what is real and what's in the world and what's in our representations of the world. Theories, for instance, of course, they refer to the world, but they are bits of human knowledge. We can also make a distinction between predicates and properties. Predicates are linguistic, so predicates include, for instance, is green. Now, the predicate is green, in fact, corresponds to a property, the property of greenness. The question is, when we talk about special science predicates, as Fodor does in his discussion, do they correspond to properties? We can't, it's not guaranteed that predicates correspond to properties because lots of predicates don't correspond to properties. So one of the key points about Fodor's argument is that one might say that a disjunctive predicate like the lower level realizer of something like pain, couldn't be a property because it's just too heterogeneous. So that's the that's the distinction. So if, when we say that higher level predicates are multiply realized, well, that may be more or less interesting, or more or less tell us more or less about the world or about our representation of it. And this corresponds to the question of whether pain is something in the world, but that is pain unified. Of course, our individual pains are there in the world, but the question is there anything in common out there in the world to our pain, human pain, and octopus pain, for instance, apart from the fact that we call them both pain? That's the question. Or is there just a sort of imperfect similarity of behaviour that we call pain, but isn't really, as the saying goes, a thing? So that's one point, getting ontologically serious. It's closely related to the instrumentalist move that I mentioned earlier on when we were talking about classical reductionism. A second way in which aspect of getting ontologically serious is to think about causation in the world, things causing things. So a question might be raised about whether non-reductive physicalism is compatible with a position that was known in early modern philosophy in the space of multiple positions about the place of the mind in the world, of epiphenomenalism. So epiphenomenalism is the view that, yes, the mind is there, it's in the world, but there's nothing causally downstream of it. It's kind of just on the end of causal relationships. It doesn't kind of do anything itself, it's not active. So whether or not non-reductive physicalism is compatible with epiphenomenalism comes down to the question of whether higher level properties are causally efficacious. So this is where a key argument, a causal exclusion argument, advanced by Jae-won Kim, has come in. Basically, the argument goes like this. Physics is causally closed. That's one assumption. We'll come back to that in a moment. And by causally closed, we mean that only physical, well, any physical event has a causal history which is entirely physical. And that's, as it were, sufficient for it. So the question is, if we think that mental events cause things in the world, including physical events, so if you think about my going to the library as an example of Kim's, I take a decision to go to the library, that's a mental event, and sometime later my body is actually walking that way. So my decision has apparently caused some atoms to move, the atoms that make up my body. So it sounds like the decision has made a physical difference. So the question is, how could it do so? Because if the physical is causally closed, so there are already enough causes for to determine how things go physically in the world, and when it just seems that there's no space for mental events to be causally efficacious, not unless there's what's called causal overdetermination. So things have more than one sufficient cause. And normally we take that to be a coincidence, like somebody being assassinated by two entirely separate groups of people. Wow, that's a coincidence, isn't it? So that's the causal exclusion arguments. We'll come back to those because they're a really very important part of this ontological term. The second part of the related to this is the idea put forward by Sidney Shoemaker in a 2001 paper and many times before, which is now a claim about realization, and this is related to the idea of causal completeness of physics, that when we have a high-level property being realized by something at the physical level, it must inherit its causal powers, whatever causal powers it has, from the physical realization. So let's think about, I don't know, opium has the power to make you sleepy. That must come down to something about the physical structure of opium. There's the thought. And there being sleepiness, the power to make you sleepy is inherited, obviously, from the causal from the physical realization of the opium. Along the same lines, in a different context, is the claim about the completeness of physics, which is pretty much equivalent to Kim's assumption that the physics is causally closed. And direct arguments for the completeness of physics are few and far between, but have been widely cited. Examples of them have been given by Brian McLaughlin in 1992 and by David Papineau. Basically, the idea is that everything that happens in the world is caused by physics laws and physical events according to physical laws. Now, this seems like a powerfully metaphysical principle, very general and very abstract principle, and the question is what evidence do they have for it? McLaughlin and Papineau think that we can find evidence in science. Let's come back to their arguments in the next lecture. At least we've given a flavour of what happens in the ontological turn, and the first part of the ontological turn is for reductionism to push back and ask about the reality and ontological seriousness of higher level causation and higher level knowledge.